Sim session is being brought to you by the Fractal Hex Rouleau Triads. This one right here. All right. So I went over this, the pendulum, also known as side-side angle. Oops, close this machine. And given side A here, side B here, and angle alpha here. And what is the third side C, and what are the two angles beta and gamma? So side-side angle. And we've done this before using the law of sines. You have side A here and alpha here. Well, here's B, and therefore from this, and this, we can find sine beta. I'll give you two values for beta, and an acute angle or an obtuse angle. From that gamma, and then from A, B, and C and beta, you can get C. So okay. If A is less than B sine alpha, then the distant side swings freely in the air like a pendulum. There's no solution. If A is equal to B sine alpha, then the pendulum skims the surface at one spot only, where it makes a right angle. One solution. If B sine alpha is less than A is less than B, then there are these two solutions, and the pendulum grazes the ground twice. And if B is less than A, then this side A skims the ground here backwards, which we throw out, so there's only one solution. All right, that's the ambiguous case. All right, now I have a formula. We go through a formula here, and I'm going to go over it, if you will. Given alpha, B, and A, find C. Now here we see the pendulum skimming ground. Here's a perpendicular F. Here's a distance E. Here's a distance E. Here's a distance to the base of the perpendicular D. And C is either this length or this length. So C is D plus or minus E, two solutions. D is B cos alpha. And so therefore C is B cos alpha plus or minus E. Well, okay, now we need to find what E is. Well, E squared plus F squared equals A squared. And F is B sine alpha. So E squared plus B squared sine squared alpha equals A squared. E squared is A squared minus B squared sine squared alpha. So E is the square root of that. And so there we go. C is B cosine alpha plus or minus the square root of A squared minus B squared sine squared alpha. And I call that the pendulum law. And I admit that I'm not really a fan of it because it's not as symmetrical as it ought to be. But okay, given alpha and B and alpha, A, B, and alpha, this gives you two solutions for C, and then from C you can get the three sides. How to find the other two angles? Okay. Well, from the pendulum law, after a bit of manipulation, we'll get the law of cosines. First transpose B cosine alpha, then square both sides. So A squared minus B squared sine squared alpha equals the square of C minus B cos alpha. This expands out to C squared minus 2CB cos alpha plus B squared cos squared. Transpose of B squared sine squared, so you get this. These two combine to B squared cos squared plus sine squared equals 1. So there we go. C squared minus 2B cos alpha plus B squared equals A squared. That's the law of cosines, which we've seen elsewhere. Okay, and interesting. Right. So therefore, and then from here we solve for cos alpha, and alpha is arc cosine of B squared plus C squared minus A squared over 2BC. I mentioned that before. I call it the law of arc cosine. Given three sides, it gives an angle. Now I use the phrase triality. It means a kind of threefold version of duality. Given a triangle, we swap around the letters, say like this: A to B to C to A alpha to beta to gamma to alpha. Same triangle with different labels, but the same identities will hold. So they come in groups. We swap around the letters. Here, the pendulum law with A in terms of C, B, and beta. Here's B in terms of A, gamma, and C. Here's C in terms of B, alpha, and A. It's symmetrical if you swap around the letters. And law of cosines, we derive that. We've actually derived that elsewhere. We get this here. And three versions of it. And three versions of law of arc cosines. And three versions of the triangle rule. Triangle rule. Okay, so for example, if if alpha is 31 degrees, B is 1, A is 1, and B is 2, what's C? Gamma and B. Well, C is B cos alpha plus or minus root A squared plus B squared sine squared. That's 2 cos 31 degrees plus or minus 1 minus 4 sine squared, 31 degrees, plus or minus 1.711433 plus or minus square root of a negative number. Oops, square root of a negative, no real solution, only complex solutions. There's no real solution to this. I leave open the question how to define a triangle with complex sides with that. A squared, 30 degrees, A is 1, B is 2. That's the same as this, only changing 30 degrees to 30, 31 degrees to 30 degrees. And okay, we go through the same deal. C is B cos alpha, so it's 2 cos 30 plus minus 1 minus 4 sine squared 30 degrees. Root 3 plus or minus root 0. Oh, this comes out to 0. So root 3 is C. And then we calculate gamma and beta. Our cosine 1 squared plus 2 squared minus root 3 squared over 2 times 1 times 2 comes to 60 degrees. And beta is the remaining angle of 90 degrees. So root 3 for the side, 60 and 90 degrees for the angles. Here we'll reduce alpha to 29 degrees. Still keep the same A and B. All right, then C is 2 cosine 29 degrees rather than 30 or 31 degrees, plus minus 1 minus 4 sine squared 29 degrees rather than 30 or 31 degrees. So you get 1.7949, etc., plus or minus the square root of this small quantity, 1.7949 for 239, plus minus 0.224619. So there's two possible values for C, the short value and the long value, 1.50 or 1.9. And from then you use the law of arc cosines in both cases, get either gamma is 46.8 degrees or 71.91 degrees. And we can get beta 104.16 or 79.09. So there's two solutions, this or this. And when doing our law of angle side-side angle problems, it's good to give both solutions. All right, so C is 1.504 with gamma is 46.8, it is 104 point roughly 2 degrees, or C is 1.993 and gamma is 71.91 degrees and beta is 79.09 degrees roughly. And okay, here I have all these cases: 30, 14, and 7, 53 degrees, 23 and 17, 42 degrees, 42 and 31, 37 degrees, 37 and 23, excuse me, 60 degrees and 4 and 2 root 3, 71 degrees, 94 and 100, 28 degrees, 1.4 and 1.5, 17 degrees, 137 and 40. And you'll notice I have room for two solutions. It could be two solutions or no solution or one solution. I'll leave it to you to do this if and when you decide to do this. 8 points. Those 8 problems. Okay, I think I'll call this done. So